We will perform near-field probing test. This is the setup for near-field probing test. We use DUT, which is corded and attended, so DUT need to be in running mode. This test have three methods. Method 1 is H-field and E-field probe sniffing. Probe set have 4 pieces, which H-field and E-field use 2 pieces each. Next, use coaxial cable to connect probe with preamplifier. Connect preamplifier to the spectrum analyzer. Make sure the attenuator limiter connected with spectrum analyzer throughout the test. Then, set the spectrum analyzer on bandwidth from 30 MHz to 1 GHz, set the amplitude reference 100 dB micro V and resolution bandwidth RBW to auto. Vertical scale to 10 dB per deviation. Next, select Trace A to measure ambient and choose View to hold spectrum. Trace B to measure spectrum on PCBA quadrant. Turn on DUT and trigger spray. Before scan the PCBA using the largest H-field probe, we divide the PCBA into 4 quadrant front and back. Now, scan the first quadrant of PCBA using largest H-field probe and take note the locations along the PCBA that produce the largest change in peak amplitude on the spectrum analyzer. Record the result and save the image of the spectrum analyzer with peak markers across the frequency band. Next, scan the rest quadrant using the same probe and we scan the backside of the PCBA quadrant. Hold this largest H-field probe loop parallel to the surface of the DUT. Save the result in waveform after complete marking the max peak. Next, use smallest H-field probe to scan the PCBA front and backside. Hold smallest probe loop perpendicular orientation to the surface of the DUT. Save the result in waveform after complete marking the max peak. Scan all quadrant front and back side. Save the result in waveform after complete marking the max peak. Then, we use largest E-field probe to scan the PCBA front and backside. Save the result in waveform after complete marking the max peak. Scan all quadrant front and back side. Save the result in waveform after complete marking the max peak. Next, we use smallest E-field probe to scan the PCBA front and back side. Save the result in waveform after complete marking the max peak. Scan all quadrant of front side and continue with back side. Save the result in waveform after complete marking the max peak. Connect the TEM cell to the spectrum analyzer and take an ambient noise reading with DUT off. Save the result in waveform. Place the DUT in the TEM cell under the septum. Use a non-conductive layer if the DUT has exposed contacts to avoid shorting to the TEM cell ground. Place DUT following the orientation 1 marking. Turn the DUT on and trigger spray. Save the result in waveform. Next, adjust the DUT to match orientation 2 as marking shown. Turn the DUT on and record the result in waveform. Next, adjust the DUT to match orientation 3 as marking shown. Turn the DUT on and record the result in waveform. For this method, we will use this RF current probe to measure RF noise present on power cord. Cut a foam spacer to center the wires in the current probe aperture. Place both L and N wires through the aperture of the current probe. Refer Figure 8A in BTP 0366. Take a measurement of ambient conditions with DUT off. Record the waveform. Next, turn on the DUT and record the waveform. Reverse the N wire through the aperture of the current probe. Record the result in waveform. Then, following Figure 8C to measure total current, I1. Record the result in waveform.